All right. So, what is so interesting about web browsers? Well, they are deceptively simple. I mean, it's just what a text field at the top and pretty much a blank page at the bottom. You type in whatever address you want, and it just opens up the web page, right? Then the browser basically just fades into the background, and it's just you and the website. We don't think much while using a web browser, but at the same time, it has become this computing platform of today. It's no longer just a way of accessing the internet. It's it's an essential computing platform, but behind that simple interface there's just so much complexity hidden that we don't acknowledge, and I thought I would shed some light on that. In fact, they're so complex that even a trillion-dollar company or multi-trillion-dollar company that like Microsoft, uh, their market cap is like $1.9 trillion, which is insane. A company as big as Microsoft ditched their web browser. They ditched Edge, if you remember, from a few years ago. In 2015, when Windows 10 came out, they had a brand new Microsoft Edge browser, which they had built from scratch. It was supposed to replace Internet Explorer, but a few years down the line, it just became too much for them to sort of play catch up with the big players like Chrome and Firefox. I don't know if we can even call Firefox a big player at this point in time. Unfortunately, Google Chrome is the dominant force, but it just became too much for them to compete and catch up at the same time because browsers are just so complex that you need a huge team and it's a lot of effort. So they decided to just ditch their own browser and adopt Chromium. So the Microsoft Edge that you see today is just Chromium wrapped in Microsoft's clothes. And I find that really fascinating. I mean, it's Microsoft, almost $2 trillion. It's insane. So where exactly does this complexity come from? I think there are a few reasons for that, and the first of which is that they've become general purpose computing platforms. They're no longer just a way to access the internet. They are computing platforms. There's a lot that goes into making each and every website that we use happen. And at the same time, they're general purpose, like I said. So they run from the dumbest of phones, not even smartphones. They run from that to like high-end workstations. So they have to be optimized for everything. They have to work on all platforms. So that's a huge engineering challenge in itself. But then we as a species lack patience. We want our web browsers to be incredibly fast, and we have no tolerance for it. I mean, we need our websites to load faster than we can click. In fact, software engineers even go as far as to optimize the loading process so that while there's something loading in the background, you're presented with something on the screen so that you're not just staring at the blank screen, even though that screen cannot actually do anything. But let's talk about this notion of a computing platform before we get any further. When the web first started, it was pretty simple. It was just a bunch of HTML documents that were served by web servers on the internet, and you use your web browser to access these, and that's it. If you don't know what HTML is, it stands for the Hypertext Markup Language, and it helps you define the layout of your web page. Your websites are written in HTML. It lets you tell the browser that, hey, here's where I want a heading, here's where I want a paragraph, a table here, and stuff like that. So it helps you define sort of the layout, the structure of your web page, and it's pretty easy to learn. You give it like 15 minutes and you'll be like halfway there. It's pretty simple. But then we wanted more because the websites from back then were not that great. They looked pretty ugly. So we wanted to add a little bit more bling to the websites, and that's where CSS came in, which stands for Cascading Style Sheets. It's this language which lets us define the styling for our websites. So it lets you change the fonts. It lets you add color and those beautiful gradients. It also lets you do some layout stuff. You can change the weight of your font and a bunch of other crap. You can also do animations with CSS, so it's pretty powerful. So what I want you to think about is the added layer of complexity with each of these technologies. So first we had just simple HTML, which by itself has grown a lot since then. But now we have CSS, which adds styling on top of HTML. And finally, we have everyone's favorite, which is JavaScript. So Even with a little bit of structure and style, they're still static documents, right? You can't actually do anything with those websites. So we wanted interactivity. We wanted to be able to, click on buttons and make something happen, or type in something in a form, and whatever. We wanted our websites to be a little bit smarter, and the way to do that, or rather the way we ended up doing that, unfortunately, is JavaScript. uh, I say it sarcastically because it's actually a pretty badly designed language, but it's what we are stuck with at this point. So JavaScript is basically the brains behind the beauty, and it lets you add logic to your website, and it runs right in your browser. And well, JavaScript is an entire language, so think about all of the complexity that comes with it. So your browser basically has to understand all of these languages. Every time you open a website, all of this crap gets downloaded from the web server, and it's your browser's job now to make sense of all of this, tie them all together, and present a website in front of you that you can actually use. And that's where the complexity lies, because these languages, these pillars of the internet, as I like to call them, HTML, CSS, and JavaScript, have grown so incredibly complex with time. It's been what, like 25, 30 years since the web first came out. These are massive languages today. They are not what they used to be 25, 30 years ago. I mean, look at the standard specification document for JavaScript. It's almost 900 pages long. The one for HTML is more than 1300 pages long. And well, browser vendors have to implement all of this stuff. And to make matters worse, there's a lot of edge cases, and the web is designed to be extremely fault tolerant. So even if the code that the browser receives from the website is like wrong, incorrect, ambiguous, it doesn't matter. It's the web browser's responsibility to present something, to kind of make sense of it and present something. So that's pretty hard to do. I mean, imagine doing that. And then to make matters even worse, web browsers have to be correct, and they have to work very similarly. So if Chrome is displaying a website a certain way, or even worse, if it's displaying a wrong piece of code a certain way, then a smaller browser would have to do the same, because then people are going to complain, oh, it looks different on Chrome, because Chrome is just that dominant. And I mean, I'm just giving an example here, but it's something that all browsers have to do. They have to be correct. We can take that thing for granted. It's easy to do that, but this is actually pretty hard to do, as you could probably imagine. So I hope that by now it's pretty clear that modern websites are no longer just documents as they used to be back in the day. They are full-fledged applications that run within your web browser. As a matter of fact, these days people don't even write HTML and CSS anymore. They just do everything with JavaScript. With the rise of frameworks like React and Vue, and I don't know, whatever happens in JavaScript land, there's a bunch of frameworks. There's a new framework popping up like every other day, which is doing the exact same thing but slightly differently. That could be another video in itself. But yeah, I mean, it's just getting more and more complex. And if you think about it, with frameworks like React and with all of these frameworks like React, which do everything with JavaScript, it's putting a lot of pressure on JavaScript engines, because now they are the main workhorse. They have to do everything, and they have to be incredibly performant. And we didn't even talk about the whole resource utilization and energy consumption part of it. We want our browsers to not hog up all of your RAM. We love to joke about how Chrome eats up all of our RAM. So it's desirable to keep memory usage down. And since browsers run everywhere, on phones and laptops, which run off of batteries, we want to be very cognizant about the fact that browsers are not eating up, through your battery as well, so that your battery life is prolonged. So I'm sure that makes things tough as well. As you can imagine, this puts a lot of pressure on browser engineers and browser vendors, because they have to come up with really smart and efficient ways to handle all of this complexity that's constantly being thrown at web browsers, and all of the evolution that happens with these technologies. I mean, HTML, CSS, and JavaScript are just the most fundamental pillars, I would say, but there's a lot more that happens in a browser, stuff like WebSockets, and they have to handle all of these different kinds of files, like images and GIFs and videos, music. There's really advanced stuff in web browsers today as well, like WebGL, which allows you to access the GPU. There's a bunch of web APIs which are really advanced. But the thing that puts web browsers in a different position is, I mean, think about this. Think about, like, pick any pro tool, let's say Blender or DaVinci Resolve, which is what I'm using to edit this video right now. We, as users of these pro tools, which are also really complex and they have a lot of features, they eat a lot of, they consume a lot of resources, we are far more forgiving if these tools are more demanding, performance wise or system wise. It's okay if DaVinci Resolve doesn't run quite as fast on my computer. I'll just blame my laptop. But when it comes to web browsers, we're not going to be that lenient, because these are not specialized tools. These are general purpose uh, tools, essential tools that we use every day. So I think that presents an additional challenge. I think the same case can be made with something like, let's say, AAA games, which are also really, really complex, and they're doing a lot. They demand a lot of just raw compute power. But we are obviously far more forgiving. If a game doesn't run well on your computer, you're just going to be like, my laptop is crap. But you're not going to see the same about Chrome or any web browser for that matter. There's a couple of more things that I just briefly want to mention. So I like saying that HTML, CSS, and JavaScript are the pillars of the internet. And it's interesting that even after all of these years, even after uh, and even with all of the evolution that has happened with these tools, they have grown a lot. There's constantly features being added to these, and yet they are still the three pillars of the web. We have technologies that are also part of web browsers today. As I mentioned, stuff like WebGL or WebSockets, but these are still things that you access with JavaScript. There's more stuff coming up like WebAssembly, which does introduce a new pillar for the internet, but still, by and large, websites are written with HTML, CSS, and JavaScript. And I also talked about how there's a new JavaScript framework coming out every other day. Even if we talk about React, which I think is the most popular one, React has its own programming language called JSX, which is basically JavaScript, but you can also write HTML code within JavaScript. Now, obviously, your web browser, if you throw JSX at your web browser, it's not going to be able to understand that. So it needs to go through a compilation process. So there are tools like Babel and whatever, which take in JSX and spit out like vanilla JavaScript. I think that's fascinating. I love this notion that we have this platform that we have built now, and we are building abstractions on top of it to kind of make our lives easier. But at the core, we still have HTML, CSS, and JavaScript. I have my issues with JavaScript. It's a pretty terrible language, but this is nice. It's nice that the pillars remain the same. As I said briefly again, there's WebAssembly coming up, which is kind of like bytecode for the web. That's, I think, another video in itself, but I think that would qualify as a new pillar for the web. I also talked about how Microsoft ditched their own Edge browser and adopted Chromium and made another Edge out of it, which says a lot about browser competition, because it's actually really, really fierce. So back in like the early 2000s, browsers, in the browser space, the biggest player was Internet Explorer, and people didn't really love it, I think. But they were just stuck using it because most stuff worked on Internet Explorer. And what's interesting to note is how this whole browser landscape has changed since Chrome came into the picture. If we go back around a decade ago, we had a lot of variety in the whole browser space. We had Internet Explorer from Microsoft, we had Google Chrome, of course, we had Opera, we had Firefox, we've always had Safari. We had something called Rockmelt that I used to use. I don't know if anyone actually remembers that. I don't know if we had Vivaldi back then, but there was a lot of competition. There was a lot of healthy competition in the browser space. These days, most of these browsers have ditched their own engines and they've just adopted Chromium. Uh, Microsoft Edge, we talked about. We also have Opera, which no longer makes their own engine. Vivaldi is also just based on Chromium. We have Brave, which is again just based on Chromium. Um, So the only independent web browsers these days, which are not Chromium, are Firefox and Safari, at least the major ones. I mean, there are some really interesting efforts, and I do want to mention one which I am a big fan of, which comes from Serenity OS by Andreas Kling. He's making, he and his team rather are making an entire operating system from scratch, and like literally from scratch. They are not using any libraries, any pre-existing code. They're writing everything from scratch, including their own web browser. So that's a massive undertaking, and I wish them best of luck. It's really interesting. You should totally check that out if you're interested. That's pretty much it. That's all I wanted to kind of shed light on in this video, because these are tools that, again, these are tools that we use every day, and it's interesting to know a little bit more about them and all of the things that go with them, go into making them. And I hope this was informative. If you have any more thoughts to share, please leave them in the comments. If you love this video, leave a thumbs up. Do subscribe if you found this useful. And yeah, please tell me if you want to see videos on any more topics like this, so that I have some ideas. I'll see you next time. Bye bye.